Good morning, everybody. My name is Chris Scanlon. I want to thank you guys for hopping on today. Today we are going TechLogix, and we actually have Cameron on the phone from TechLogix. Cameron, are you there?
I am. Good morning, everyone.
And before we get started, I also just say we do have a lot to cover. If you guys have any questions, just please questions box, and we'll take as time as needed after the webinar to answer you guys' questions. So, Cameron, what's going on with TechLogix?
Well, we're going to be talking about fiber optics today, and a lot of people are interested in fiber. Obviously, it's becoming a big part of the audiovisual installation. We all need to be thinking about it for things like 8K and networking. TechLogix does the CEDIA fiber trainings, one of the main ones. So anybody who's going to CEDIA in a week or so, if you're taking a class on fiber, you may be taking it with us. And the deck that you will be seeing today is basically a truncated presentation that will go over the kind of the hows and whys and what's of fiber.
And Cameron, do me one favor real quick and hit the big play button that says show my screen.
You know, I don't have that option. It's grayed out for me right now. I was kind of waiting for you to give me that control.
Oh, okay. I apologize. The wrong person present. There you go. Now you should
Perfect.
be ready to rock and roll. Thank you.
All right. We ready to go?
We are ready to roll.
All right. Let's jump into it. So typically I like to start these webinars and these trainings with a couple of notes here. There's a lot of people on the call today, so go ahead and type any questions that might come into the little chat window there. We'll get those towards the end. This deck usually takes 30 to 45 minutes to run through. It's a little bit different than the deck that we do in person. So when we do a training in person, a fiber training in person, we get into a lot of the hands-on where you learn how to physically terminate. You learn how to test the cable runs and certify things. Obviously, it's hard to do that in a webinar format. So what we'll be looking at today is more of the, as I mentioned, the how fiber, the why fiber, where are we using fiber, really why is this becoming a very important part of the AV conversation. So with that, let's start by talking about that infrastructure. I like to call it media over fiber optics. You know, some people call it HDMI over fiber or AV over fiber. The reality is any place we were using category cables, so like Cat 5, Cat 5e, Cat 6, we can start using fiber. There's only one exception to that, and it comes into power. We'll talk about how we deal with things like power in fiber. There's pros and cons. Again, we'll look at all that. But the important thing here is it's more than just the AV signal. That's why we call it media. We're talking about control signals going over fiber. We're talking about things like USB, obviously networking, and then of course HDMI, DVI, DisplayPort, all these other signals that we traditionally have to look at broadcasting throughout the home, broadcasting throughout the commercial environment. So there's a lot that goes into this conversation. Now the good news is, even if fiber is relatively new to you, it's really not that foreign of a concept. When we look at the ecosystem, all the different components that goes into wiring for fiber, it's really not that difficult. And what I mean by that is there are things like bulk cable, right? You got to be able to pull a cable, you got to be able to terminate it, you got to be able to put it in the field. Fiber is really no different than the category cable you've been working with. Patch cords, pre-made cords, specialty cable, you know, and when I say specialty, I mean things like direct burial and armored cables, outdoor rated cables. So all of these things are available in the fiber optic installation. But what I find is very important and interesting here are the electronics. So the electronics are a very important recent development in the AV market. You know, frankly, electronics just didn't exist to leverage these fiber optic ecosystems for traditional AV deployment up until recently. We'll look at kind of what those are, how those work, why those are playing into the installations that we're all working with. But before we get into that, let's talk about why fiber. So this screen should be pretty familiar for anybody who's been in the industry for a long time, right? We're familiar with standard def televisions and displays, right? That 4:3 aspect ratio. You just don't see a lot of that anymore. We've seen this evolution going into 1080p, and now we talk about 4K HDR, right? High definition video. This has been really a great conversation for copper infrastructures. That's why we've used HD-based T extenders and twisted pair extenders for years and years and years. They're great for sending things like 1080p video. 1080p, you're dealing with about 4 gigs worth of bandwidth. A 10 gig cable, which is where copper maxes out. So if you think of that Cat 5e cable, that Cat 6 cable, that maxes out at 10 gig. It's great for 1080p or 720p or 1080i. Works fine. But now 4K video comes along. And depending on what we're doing with the signal, if we're using HDR or if we're doing 4K 30 or 4K 60, 444, all of a sudden that bandwidth starts to get up above 10 gig. And what we see, this max bandwidth threshold for a 4K 60 444 HDR signal, that can go all the way up to 18 gig. So by looking at these charts, we got a 10 gig cable that is trying to handle an 18 gig signal. Now, it's not impossible. Anybody who's in the industry, it can be done, but it has to be done with compression. So you've got these extenders out there that'll take that big signal, compress it down to a smaller signal, and broadcast it over the cable. It works. It's not ideal, but it's possible. Now the conversation shifts. 8K comes along. And 8K, it should be noted, 8K is not like 4K or 3D, okay? There is a lot of content for 8K. So anybody, and I always use this analogy, right? Anybody who watches sports, that they'll do a freeze frame, in the instant replay, and then they'll zoom in on the goal line or zoom in on the pitch. That zoom is not a function of the camera lens. That zoom is a function of that signal being filmed in 8K. You have the resolution to zoom in and get a very, very clean, clear, high resolution image based on this image, this picture that's being processed by the camera. It's an 8K signal. TV shows are being filmed in 8K. Movies are being filmed in 8K. So there is a lot of content. The problem has been there's no pipe to get that big signal to the home. Well, that's all changed because fiber to the home and more people are using broadcast streaming through the internet, things like Apple TV and Sling, and there's a bunch, DirecTV now, there's a bunch of different services that allows you to download your signals and get higher resolutions out of that. But it also it also plays into the actual displays. Well, in January, the HDMI 2.1 spec was released. The chips are in production. You will now be seeing 8K consumer electronics hitting the market. 8K goes all the way up to 48 gig. It is not feasible to take a big signal, a 48 gig signal, and packetize that down, compress that down to run over a 10 gig cable like a Cat 5 copper-based cable. So now we have this big problem, this big signal, and we got to find a way to get it over some sort of a cable from point A to point B. The punchline is this is where fiber optics come into play. That fiber cable is made to take these high bandwidth signals and move them from point A to point B. But it's not just AV. It's also networking. We can look at the average middle class home in the United States. Today we're dealing with about 25 different devices that are connected to the internet. I mean, we think of things like our phones and our computers and our tablets, but really you're seeing a plethora of appliances, toys. There are all these connected devices in the home. That number is expected to double over the next 2 years. It's putting a strain on that bandwidth infrastructure. So as we start looking at how do we future-proof our installations, whether it's AV distribution, making sure it's future ready for 8K, whether it's the networking distribution, making sure it can handle all the bandwidth of all these connected devices and the streaming media players that want to handle all of this type of bandwidth, we're really talking about an infrastructure that is fiber optic based. And that's one of the things that we look at here at TechLogix. Now, there are some other inherent benefits of working with fiber. Okay, I mentioned when we all jumped on the phone that fiber does not transmit power. That can be one of the downfalls that we talk about, and really the only downfall in my opinion. You can't power devices with a fiber optic cable. It just doesn't transmit power. There's an advantage to that, however. By not transmitting power means you have indemnity from things like surges, from lightning strikes, from static electricity. All of these things that can take down electronics are not a problem with a fiber optic infrastructure. It's immune to all of that. The other advantage is things like electromagnetic and RF interference, right? We think about that traditional Cat5 installation, right, where we've got our HD-based T extenders. I'm willing to bet that the folks on this line today who are listening to this presentation, you have done a twisted pair extender installation. You have had an installation where everything works great. You get it installed, you leave site, and then you get a call. A week later, maybe 2 weeks later, picture drops out. You go on site, you reset the power, power cycle the extenders, picture comes back, works great. A week later, you get a call, it's out again. That typically happens because of electromagnetic or RF interference. Basically, this interference is disrupting the signals that are transmitting over this Cat cable. And by resetting the power of these extenders, it brings the signal back. You don't have those issues with fiber optic. It's way more stable because it's immune to all of this interference. And then, of course, there's some other advantages. Distances. Fiber can literally send these high definition signals miles. So you've got long distance transmission. It can handle all the bandwidth, as I mentioned, for networking, for data, for AV. And then you also get into some things like corrosion. Fiber is immune to corrosion. And very importantly, and we'll look at this here in a little bit more detail, we can handle it easily and cost effectively. And that wasn't always the case. Historically, it costs a lot of money to get into fiber. You'd have to get some real specialized equipment, some specialized training. But today, anybody can learn how to work with this, with about 10 to 15 minutes worth of hands-on, learning how to terminate or watching a video online. And the kits to terminate and install are about $500. So it's a completely different expectation today than it was even 2-3 years ago. So fiber is really easy to get into, really cost effective. Now let's talk about the actual cable itself. There are 4 main physical constructions that you're likely to encounter as you're getting into these fiber optic infrastructures. Simplex fiber. So some people call this one conductor. Fiber doesn't conduct. We call it a strand count. So how many different strands of fiber are you working with? Simplex fiber has one strand. So there's one strand of fiber connecting the 2 points of distribution. Very rarely will you pull simplex fiber. And the reason for that, even though that some AV gear, we at TechLogix, we make AV gear that uses one strand of fiber to transmit, you still don't pull it that much. And that's because in the networking world, almost always you have the need for duplex fiber, 2 strands of fiber. One strand is transmitting, one strand is receiving. That is the network standard. And because of that, you will almost always pull duplex fiber, and you will almost always buy it in a zip cord construction. That is just how it is standardly manufactured. Now, you do have multi-strand options called breakout fiber and micro distribution fiber. That is where we take those strands, we put them all in a single jacket. So you've got basically a bundled cable. And these breakout cables and these micro distribution cables are available in a bunch of different strand counts, from 4 strands to 6 strands, 8 strands, 12, 24 strands, and even really thick trunk cable for those really large installations. More often than not, what we see going out there is 4 strand, 6 strand, or maybe 12 strand fiber. We'll look at the difference between these here in a little bit more detail, but do know that the majority of the time you're pulling duplex fiber, which is 2 strands. When you get into the need for having more of a trunk from point A to point B, that is where you're talking about breakout fiber or micro distribution fiber. Now, the cable itself, there's a couple of different parts that play into fiber that makes it really durable and easy to work with. So, of course, what you see is the cable jacket. This is the outer housing of that cable that we work with. Most cables have some sort of a cable jacket. One of the keys to a fiber cable that makes this so different is the strengthening fibers. So we call this aramid yarn. This is Kevlar. In most cases, this is actually Kevlar yarn that's inside the cable. And what the Kevlar yarn does is it gives it a lot of strength and, depending on your cable construction, also waterproofing. So there's gel on this yarn that gives you waterproofing inside the cable. Now, when I say that this Kevlar gives it strength, I really mean it gives it strength. So depending on the cable that you're buying, this can have up to a 220-pound pull rating. So this cable is actually stronger. This fiber optic cable is actually stronger than just about any twisted pair cable or coax cable that you've worked with in the past. It is incredibly strong, and that's thanks to that aramid yarn, that Kevlar inside of it. And then you have the cladding, which is an outer coating, and then the core. The core, in most cases, and it depends on the kind of fiber that you're working with, it's glass, right? And when people think of fiber optics, they think of glass. Now, traditionally, glass meant you could have some issues. It broke easy, okay? It would fracture, breaking the cable. When you handled it, you needed to have special gear to protect your skin, protect your eyes. You'd have to do it in a clean environment to make sure there were no glass shards. Well, the good news is modern fiber optic cables that we're working with today, they really aren't constructed in that traditional sense. Now, there's still glass, but what you're seeing polymer coated glasses. So you can literally tie these fiber cables in knots and they don't break. And if they do break, the polymers hold those breaks together, so you still have the transmission of AV signals and networking signals through that cable. So again, you can, and this is a great presentation, right? Anybody who's done these hands-on trainings where you take the cable, you learn how to terminate it, you run the laser through it so you can actually see that laser lit up, and then you tie this cable in a knot and pull on it as hard as you can, and you see that it's still transmitting signal. That's what you get out of modern fiber. Now, the other parts of the construction, because there's polymers on the outside, and when I say polymers, this is really what's known as an SSF technology, stronger, safer, faster technology. We see it a lot in the AV market. Basically, because this polymer is on the cable, it allows us to handle it. We can terminate in less than a minute. There's all kinds of advantages to working with these fibers. And for anybody who's new to it, I definitely recommend a hands-on class. And I also recommend, taking a look at some of the videos online. They're really, really intuitive. Now, before we jump into some of the conversation around the electronics, let's talk about the different construction types, the types of actual fiber. Two main things that we're going to be running into: single mode and multi-mode. The difference is the core size. So that core, that glass in the middle of the fiber optic cable, the core size is smaller in a single mode fiber versus a multi-mode fiber. And because we have a smaller core size, we typically will use single mode to go longer distances. And that may be a little counterintuitive. People think, well, if I have more glass, a bigger core size, that means I can go further. That's actually not the case. And we typically tell people, kind of rule of thumb here, installations up to 1,000 feet, we go with multi-mode. Bigger core, up to 1,000 feet. Over 1,000 feet, we go single mode. Smaller core goes longer distances. And the reason behind that is because in a fiber optic, an optical setting, you have light. And that light refracts off of the outer jacket of that optical cable. Or, I'm sorry, the inner jacket of that optical cable, the cladding around the core. And in a multi-mode cable, that bigger core, that light can get out of phase. So it can get out of sync, right, as it travels through the cable. And that means as we start to exceed 1,000 feet, as these signals get out of phase, we lose the integrity of our signal. Now, a nice small core, like in a single mode cable, that keeps everything in phase for much, much longer distances. And when I say much longer distance, I mean we can legitimately take a 4K HDR signal, high bandwidth signal, right? We're talking about 18 gig. We can take 8K signals, 48 gig, networking signals up to 100 gig. We can literally send those signals kilometers, miles. That's what these single mode cables allow us to do. And from a cost perspective, there's not a huge delta between a multi-mode cable and a single mode cable. Single mode is actually a little bit less expensive than a multi-mode cable because there's less glass in it. However, the electronics on the end of it are a little bit more expensive. So again, what are you pulling in a day-to-day basis? If you're going under 1,000 feet, which is most, residential and even most commercial installations, you're going with a multi-mode cable. If you're going over that 1,000 feet, that's where we're seeing single mode cables come in. And this is a core part of a lot of the training that we do, the fiber optic guides that we put out there. And most of what you're going to be reading in the industry, it's all about multi-mode up to 1,000, single mode over 1,000. Now let's talk about connectors, okay? There's 5 different types of connectors that you may encounter in your installations. The good news is really only 2 of them are relevant for audio video installations. That's an LC connector and an SC connector. The ST style, the MTRJ style, and the MPO, those are where we're starting to get into data centers and some really heavy broadcast installations. You just don't see it a lot in that traditional AV installation. It's almost always an LC or an SC. The SC style is what's been traditionally used. So that was one of the original connectors that they used on a lot of the networking gear. It's a bigger connector. Because it's bigger, it's a little bit easier to terminate just based on size, but the process is identical, whether you're doing an SC or an LC. On modern networking gear and on most modern AV electronics, you are using an LC connector. That stands for a Lucent style connector. It is a patent. And because it's a smaller connector, you can fit more connections on the physical AV gear. That's why a lot of manufacturers are turning to the LC connector now. Anybody who's familiar with things like SFP modules, right? These are little fiber optic modules that slide into network switches and routers. Those are almost always LC style connectors. Now, the good news is if we are getting into an installation, right, where we may have bought or terminated LC or an SC style, but we need to adapt it, there are adapters out there. There are crossover cables out there. These 2 connectors really perform interchangeably. You still have all of the advantages of the fiber optic cable. It's not the end of the world if you have one or the other. But do know that most of your installations you're going to be running into an LC style connector. Some of the older equipment will be having an SC style connector. Now, This is where the conversation that we have on these webinars deviates a little bit from the hands-on book training. We always like to talk about the different parts of the TechLogix ecosystem. This is particularly important with all of our partners at Capitol Sales. This is all the stuff that you see when you are working with the AV fiber optic installations, and this is all the stuff that you're going to have access to on web, through the catalogs, through the Capitol team. Now, there's a couple of different options for cabling. So when we think about pulling cable, there's different ways you can go with this. Most people think about bulk fiber, okay? Bulk fiber is a big part of what we're doing. Bulk fiber gives you some major advantages, right? 220-pound pull strength. You can literally tie this stuff in knots. It's got what's known as an ultra small bend radius, tight bend radius. But you got to terminate it, right? When you pull it, you got to have a termination kit. You got to put the connectors on it. What we see is in a lot of installations, especially the theater installations, people turn to pre-made cables. Pre-made cables come pre-terminated out of the bag, ready for installation. And actually, pre-made cables can actually cost less than a bulk fiber solution. These pre-made cables, because they're factory terminated, because they're all in one out of the bag, the cost can be incredibly competitive. And there are different options of cables that you'll run into, from just kind of your standard economy pre-made all the way into an armored pre-made. And actually, we see more sales kind of fall towards the armored pre-made because these have helical stainless steel inside the actual cable. So it's a stainless steel armoring inside that pre-made cable. Now you get into some other options like direct attach cables, which are pre-terminated with SFP modules. This is what you patch different network devices to, stacking switches, et cetera. But do know that there's really two different ways to cable: going with a bulk fiber, where you're going to be terminating in the field. It's really not that difficult to do, or a pre-made cable, whether it's armored or economy. And if we take a look at how these cables stack up, so this is actually three different cables taped side by side, you see that the economy is definitely going to be your thinnest cable. And we're talking about a very, very small gauge, about half the diameter of a Cat 5 cable. So very small, easy to pull. You've got a bulk solution, and then the armored solution is actually about as thick as that actual bulk cable. So when we think of armoring in these pre-made cables, a lot of people think of that heavy direct burial or an armored cable that we're used to pulling for like a tactical type installation. That is not the case with fiber. This stuff is really small, really thin, really pliable. This is how the three cables stack up. Now, you do have one other option, and that's building a custom cable. And this is something that we've seen pretty grow quickly. It's grown quickly in popularity, because there are a lot of people who are doing that 450-foot pull. They have different strand counts. They're doing outdoor type rated stuff. But basically, you are getting a cable that is all pre-built, ready for pulling. It's even got the pull mesh all built into it to put into your conduit or directly into the ground. But there's a lot of different options for cabling for your installation when we're talking about fiber optics. Now, all of this is great. All of the conversation around fiber and future proofing makes sense, but you got to have things to plug into it. And this is what I mentioned about that relatively recent developments in the AV industry. You just didn't see technology like this 2-3 years ago. These are fiber optic extenders, everything from DVI, a lot of HDMI, even things like USB. Basically, these are the products that take your AV and control signals, your networking signals even, and run it over the fiber optic cable. And these products are really designed to fit into a couple of different installations. So if we focus on HDMI, which by far is the most popular solution that most people are using out there, there are options for 10 gig HDMI, which is what we see in a lot of the commercial installations still. This is the 4K 30 1080p world. But then when we get into the theater world, custom install world, that's where you're getting into an 18 gig solution. These are the products that do 4K 60 444, HDMI 2.0, HDCP 2.2. There's two different technologies out there for doing 18 gig. There's compressed technology and then fully uncompressed technology. Both have a place in the installation. Fully uncompressed technology is what is going to give you native signal pass-through. This means that it'll take that 444 signal and natively transmit everything that comes in out of it. There is no compression. There is no altering the signal. There is nothing happening to affect the quality or integrity of that high definition HDMI signal. It is a fully uncompressed native transmission versus compressed technology. What happens with the compressed technology, basically the box takes that big signal and says, okay, we need to compress it down, take an 18 gig signal, compress it down to 10 gigs. Think that Cat5 example, right? A Cat5 cable goes up to 10 gig ceiling. Well, this box is basically doing a similar thing. It's taking an 18 gig signal, compressing it down to 10 gig, so now we can transmit it out. And the reason we do that is not because of a limitation on fiber cabling. It's because of a limitation on the networking equipment in line. So if we think about switches, if we think about different patch panels and SFP modules and all the things that might play into our infrastructure, not everything supports an 18 gig signal or a 40 gig signal or a 100 gig signal. The standard today that we're seeing is either 1 gig or 10 gig networking equipment. And there is a need to take a big signal and compress it down to 10 gig and transmit it out there. And these boxes are smart enough to look at the network infrastructure and say, okay, I need to take a big signal. I need to automatically make it smaller. And that's what these boxes do. And by putting that type of technology in the product, it means we can make the boxes less expensive, and it also means that we can take these signals, run them through existing networks, run them through new networks, and also run signals incredibly long distances. You know, I use the example of Las Vegas, where we do a lot of work with as TechLogix, and you know we've literally got fiber optic extenders running 3 to 6 miles through these massive casinos. That is because we have the technology to take big signals, compress them down so we can run them over a standard network, run them over a single mode cable that is strung out miles of length. If we look at these boxes, so this box that we're looking at on the screen, this is actually one of the fully uncompressed native extenders. I mean, really, this looks pretty similar to an HD-based T extender, right? The only difference is instead of a Cat5 port, we've got a fiber optic port. That's an LC port on there, that duplex LC connector. I mean, we have control. So just like your HD-based T extender you're probably using, HDMI, IR, RS-232, even ARC, that's all built into these boxes. So it looks a lot like that, the black boxes you're using for copper. The only difference is that fiber optic extender as opposed to the Cat5 connector. Now, the last thing that we want to talk about here before we take some questions is AV over IP. So a lot of good solutions out there on the market for taking a high definition signal and running it over a network, doing this point-to-point distribution or matrix distribution, but doing it through a network switch. TechLogix does this, but again, we do it all in the fiber optic world. And there's some major advantages to using fiber over Cat, not just about the things that we've talked about, bandwidth and distances, but also because we're deploying fiber optic technology, we can do things like 0 frame rate latency distribution, meaning that all of the signals are synced up together from room to room. And in those live installations, there are no delays. Fiber optic just simply delivers a much better performance and a much faster, higher bandwidth performance. But you can also do things like seamless switching. You can also do things like video while processing. You have the bandwidth capability to simultaneously deal with 720p, 1080p, and 4K all in the same system. But it's all because of a fiber optic infrastructure that allows us to do very, very heavy processing and very, very fast processing. So this is all part of that fiber optic conversation. Basically, everything we're doing with Cat5 copper-based installations, we can do with fiber, with the one exception of pushing power. And that means that the devices need to be powered on both sides. But because we don't send power, that means you have a cable that is immune to all of this interference. It's immune to lightning, static electricity, surges, et cetera, et cetera. So with that, are there any questions for me based on fiber or some of the technology we looked at today?
Thanks, Cameron. Guys, this is a great opportunity. Since we do have Cameron on the phone, he is an expert on the fiber world as well as extenders and everything else. If you guys have any questions, just post them in the questions box. Otherwise, I know how it works. As soon as you get off the phone, off the webinar, the question's going to roll in. Feel free to reach out to myself, your local account manager at Capitol, or reach out to TechLogix. We're all here to help you guys out. So, Cameron, do you have the questions box open? Can you see those questions that rolled in?
Sure do. So Greg asked, how do we cut bulk cable? So fiber, think of it as glass, right? We talked about there's a glass core in there. And in the termination kit, there's a fiber optic termination kit. It's about $500. It comes with what's known as a cleaver. You don't use a scissors or a knife to cut fiber. Now, you can. It'll cut it. And when you're pulling out your cable, very often somebody will use Kevlar shears, which comes in the kit. But in order to get the fiber to perform, you have to cleave it. And for anybody who's cut glass, you know that you score the glass and then you snap it to create a clean break. And that's what the fiber optic cleaver does. So in your kit, you'll get this little cleaver. You strip back the outer jacket, pull back the Kevlar, and expose that glass core. And by laying that across the cleaver wheel, it scores it and it snaps it. The whole process takes, seconds. It's really easy. It's part of that $500 kit. And, and I would recommend that, again, that hands-on training, you learn how to do all that, or you can watch a simple video online. We've got some videos on the website that kind of shows you that process and walks you through it step by step. So next we have a SFF 2 millimeter versus 3 millimeter explanation from Anthony. I guess I'm a little confused, Anthony. If you could just type in a question to kind of clarify if we're talking about fiber, the connectors, the SFP modules. I'll give you a minute to kind of put that in there. And average cost of a termination kit, Don, $500. That's about what those termination kits cost. That even comes with a VFL, so it's basically the laser that will send the light through the cable, so you can see the cable light up, and it kind of helps you terminate. And it's easy if you've got a bad termination. And then for an extra $500. You can also get into test kits that'll actually meter out that cable and give you your link budget. Your link budget is basically your loss profile. So how much loss do you have on that fiber cable run? And this is part of when we get into the big, trainings, the CEDIA trainings where, we're sitting in a room for an hour or 2 hours. We get into link budgets and how much loss you can have on the run and how to use the meters and things like that.
And then just so you guys are aware, we do have both the termination kits and the testers in stock at Capitol. So if you guys need any or have any more questions on those, you can reach out to us and we'll be happy to help you out.
Yeah, so we've got a good question here from James. So if we've got single mode service from the road, basically, and this is very common, right? Very common question that we get. Single mode cable is what takes the signals, the internet service provider signals to the home. And you typically go into a demarc point, right? That's where it terminates. And then in the building, we typically have multi-mode cable. So single mode on the outside of the cable or on the outside of the house because it's long distance, multi-mode inside the house because shorter distances is typically what you're seeing. How do we put those two things together, right? So single mode fiber and multi-mode fiber are two different core sizes. Two different, not the connector sizes aren't different, but the actual core that fits into them, the cable that fits into them, that glass inside, they're different. And those two things don't butt together. They don't connect. You got to basically take your signal and step it down. And in most installations, that demarc point becomes very important because a single mode is going to come into the demarc. That is where typically you will have your modem. And then from that modem, you will tie into the network switch, or maybe you'll tie into the rack. And from there, we go out multi-mode. Now, if you want to extend the demarc point, then you will run a single mode cable from there to wherever that modem's going to live. But we don't take a single mode cable and directly connect it to a multi-mode cable. It just doesn't work that way. Hopefully that makes sense. I'm happy to, expound upon that, James, if you want to give me a call. Or, we've actually got a little guide here, and I'll tell you what, let me take a minute to pop this up on the screen. And I believe this is on the Capitol website here. All right. So this is a little pocket guide that we have that kind of goes over all these different things that we talked about today. Wi-Fiber, the bandwidth analysis, the network analysis. We even talk about how you mark this stuff up. Typically people are marking up the cable price by about 3 times. So there's a lot of profit in fiber. But what I wanted to show you here as I flip through this is, here's the termination step by step. So this shows you where fiber is being deployed in most typical residential installations. And we have similar white papers for commercial installations as well. But this kind of shows you if you're doing security and access control, you have that service demarc to the main distribution point. If we get into rack-to-rack installations or just general residential pre-wire, how do we future-proof? In an ideal world, what cable are we going to be pulling? This handy little guide walks through all of that kind of stuff. But definitely demarc ties into that conversation, and typically there's a modem in between. So a couple of other questions that have come in. Folks who are looking for bulk 12-strand single mode. There's different ways that we'll price these out. I mean, there's obviously going to be a lot of your stock fiber, stuff that people are buying for 90% of the applications. But then, contact Capitol. Use the little online design guides. You're going to be able to specify 12-strand, 6-strand, 24-strand, direct burial, any lengths, bulk, pre-terminated. Really, the sky's the limit. TechLogix has over 10,000 SKUs of fiber-related products, fiber-related cabling and accessories and things. We don't put it all online. We don't put it all in the price list. A lot of this stuff, you would just go to Capitol, tell them what you're looking for, or use the handy online calculators and handy little online design tools, and that'll help us narrow in on exactly what you're looking for. Question, CEDIA. We will be at CEDIA. We'll have some fiber accessories and the little fiber pocket guides in the Capitol booth. TechLogix also has a booth, number 1917. We will be there, and we will also be doing a lot of the hands-on fiber trainings. We'll be doing that on the show floor, or if you're taking any of the fiber classes, I'm teaching several of them. We'll go back. SSF, I'm sorry, I'm just flipping through. There's a bunch of questions here. Breakout diameters. Yeah, there's different ways that we will construct a cable. So if you're getting a distribution cable, okay, that's where you've got a bunch of strands, so maybe 4 strands or 6 strands inside an individual jacket, a single jacket. You can get those distribution strands broken out at different lengths, right? So you have more cable to work with for connecting to different switches, or keeping it tighter together. And typically that follows the pre-made, because when we're building a pre-made cable, we can build that in different lengths. I'd recommend, Anthony, if you want to just give me a call offline, we can talk through a lot of the different options for creating SSF breakouts. Let's take a look here. Same mode fibers. So we've got a question here about loss, and there is loss every time you are connecting 2 different cables together, or you're going through a patch panel, or you have different types of connections. And that's where that link budget that I mentioned comes into play. The link budget is how much loss your different electronics or your different devices can tolerate before you have a loss of signal, okay? And stuff doesn't perform anymore. Most link budgets are between 3 dB and 11 dB. So like extenders, fiber optic extenders, those need to stay within 3 dB of loss. Whereas a lot of the networking equipment can tolerate up to 11 dB of loss. Rule of thumb, every time we throw a patch cord in line, or have an adapter, or some sort of, like a keystone, you can calculate 0.2 to 0.3 dB of loss. It means that you can have 10 to 12 different connections in line before you really start to affect the integrity of that extender. But this is where it becomes very important to get your meters, to really understand good termination standards, and narrow in on just best practices in the field, how we make sure we're cleaving properly and setting that connector properly, et cetera, et cetera. But that link budget, that loss, can negatively affect your installation. Know that you've got typically on the small side of it about 3 dB of loss. All right. I don't see any other cables or any other questions that have come in. I'll give it one more minute.
And guys, if you guys have any questions, after the webinar, feel free to reach out to myself, reach out to your account manager at Capitol or TechLogix. We're all here to help you guys out and answer any questions. And Cameron, I want to thank you for taking time out of your day to teach us more about fiber, teach us about some of the options that TechLogix has. I know we're all busy, and I want to just thank you for that.
Yeah, appreciate everybody's time today. It's a lot to cover in about 45 minutes, but definitely feel free to reach out. We can walk through this stuff one-on-one.
It looks like we have one other question that popped in, splicing.
So, yeah, there it is. Splice kit. So there's different, in a splice kit, typically you're looking at a 0.3 dB of loss, and it's certainly possible to splice cables together. We see it all the time. There's different ways you can do it. You can use a mechanical splice, which is the easiest, but typically those have 0.3 dB of loss, meaning you can do a whole lot of splices before you start to exceed that link budget.
And as for the, is this webinar recorded? Yes, it is recorded. It'll get put on actually our YouTube channel, Capital Sales YouTube channel, just like all of our webinars. So whether it's this webinar or any of the webinars in the past, all of them are able to be viewed right on our Capital Sales YouTube channel. So if you want to brush up, remember later, we all know how it goes. You can learn now, and the next, 3 months down the road is your first or your next fiber, job, and you got to refresh. You can hop right online and we can review it right there.
Yeah, and then we had one more question come in. The termination kit per connector, that's 0.2 to 0.3 dB of loss as well. And that's pretty standard. When you look at even like patch cables, you'll have basically a loss spec on there. And if you're doing a quality cleave, you're doing a quality termination, and that's with the VFL that comes in the actual termination kit, you can see that light loss. Plan on 0.2 to 0.3 dB of loss. That's pretty standard based on most all the electronics most of all the accessories we see out there. All right. We've got another question in here. How to connect two existing Luxel switches between buildings, 150 feet apart. So, I can't necessarily speak specifically to Luxel. We work with all kinds of different. Yep, go ahead.
It really depends on which Luxel switch. Most of the managed Luxel switches have either an SFP port or an SFP plus port. So that it really depends on which switch you're working with. But with that being said, we can use the standard SFP or SFP plus transceiver modules and go to your LC multi-mode connections. So with that info, if you want to add anything more to that, Cameron.
Yeah, and I'll tell you that's typically what we see depending on, all the different switch manufacturers. You do have some options for that. So if you were going to connect two switches with the SFP or the SFP plus ports, that's where you would use bulk fiber, pre-made fiber, and then that SFP module. Now, if these two switches live in a rack close together, a lot of people don't know that direct attach cables exist. This is really what you want to be using. They're cost effective, they're factory manufactured. It's really a fraction of the price of an individual SFP plus bulk cable or pre-made cable. But these cables essentially have the SFP hard terminated to them. The only downfall is they max out at about 7 meters, which is like 23 feet, something like that. Okay.
So if you have a specific instance, definitely reach out to myself, your account manager, or Cameron. We can work on getting a list together, what transceiver modules you want depending on the switch, and then what other types of connections, if it's a pre-made cable, or bulk, so we can get you your termination kits, your testers, everything. Is there any other questions, guys? Well, if there's no more questions, Cameron, I want to thank you again for taking time out of your day. And then if you guys have any questions pop up, like I've said a few times, feel free to reach out to any of us. We're all here to help you guys out with any projects that you guys may have.
All right. Thank you, everyone. And thanks for setting this up, Chris.
Hey, no problem. Thank you, Cameron. You guys all have a great day, and hope to hear from you guys soon.